All right, so we are on learning objective 8, which is to write names and formulas for acids. Acids contain hydrogen. And it's the hydrogen ion, so the ion of hydrogen, which is H+. Okay, these guys are always aqueous. And the abbreviation for aqueous is AQ in parentheses. Otherwise, they are considered molecular compounds. But this is where they're named as ionic. I mean, because who makes these rules up? I don't know. So they're named as ionic. I can't help it, guys. So if you see them and they're in a different state than aqueous, just name them hydrogen and whatever the anion is. Okay, so hydrogen chloride, hydrogen bromide, hydrogen iodide. I mean, it's just how it is. Okay. First thing that you do when you are naming an acid, you need to identify the cation as hydrogen. So the cation is hydrogen. That means, what this means is when we recognize the cation as hydrogen, it's aqueous, that means that the second word, so the second word in the name, because remember, most names have two names. The second word in the name is acid. Okay, so the second word in the name is acid. So then we've got different ways that we can kind of look at these, because we've got three different suffixes for the anions. Okay, so we've got three different suffixes for the anions. So the anion with oxygen, which this is going to be a polyatomic ion. Okay, if I have 8, the ATE ending, so I can only have, if I've got a polyatomic ion with oxygen, it's either 8 or ite. Okay, if I have the 8 suffix, then this is going to change to the ic suffix. If I have the ite suffix, I'm going to change ite to ous. Now, if I have an anion that is without oxygen, so if I've got the anion without oxygen, it is either a nonmetal or it is cyanide, which is Cn minus. Okay. I'm going to add the prefix hydro. I'm going to change IDE to ic. So then what I have is the hydro root. So the root word for the element name, ic. Okay. So let's look at a couple of examples here. We've already done these two in class. So hydrogen HCl is hydrochloric acid, and H2SO3, which is sulfurous. So H2SO3 is sulfurous. We have not done H2CO3. So then H2CO3, H is signifying that I have acid, right? And then I would need to go and look on the back of my periodic table at my reference sheet for CO3. So I have CO3, it's right there. That would be carbonate. So if I've got carbonate, I've got carbonic acid. So this guy is carbonate. I'm just changing the ATE to ic. So carbonic acid. So carbonic acid. So anytime you drink a soda, you're actually drinking a little bit of carbonic acid. But you didn't know that? All right. So writing formulas for names for these guys, for acids. We're going to identify the word as acid. So identify the word acid. This means that hydrogen is the cation. You need to be able to identify the anion. Again, if the prefix is hydro, so if I've got the hydro prefix, I have no oxygen in the formula. So from the period, so these guys are from the periodic table, or it's cyanide, which is the N minus. If I have the suffix ic, no prefix, just the ic, okay? So if I have ic with no prefix. So if I've got ic with no prefix, that means that I've got a polyatomic ion. With the ate suffix. Okay. If my suffix is ous, again, this is with no prefix. The only one that has a prefix is my one that doesn't have any oxygen, has the IDE. So like these guys have the IDE suffix. Okay, cyanide, oxide, nitride, phosphide, so forth and so on. Again, if I've got the OUS, it's a polyatomic. Ion with the ite suffix. Okay, so ite suffix. The absolute value of the charge. Of the charge on the anion is the subscript on hydrogen. So in these examples, all right, so I've got hydrobromic. So I'm going to take out hydro. I know it goes to IDE. So I've got bromide. I automatically have acid, so that means I've got hydrogen. So it's hydrogen bromide. So bromide is Br, and it's got a -1 charge. So it's HBr. Benzoic. All right, so let's look at benzoic acid. So I don't have hydro here, so that means it's not IDE. So it goes to 8. So I've got benzoate. And I know acid stands for the fact that I have a hydrogen, right? So I go to my periodic table and I look for, oh, there it is, it's benzoate, C7H5O2, and it's got a -1 charge. So that means that I have 1 hydrogen atom. So C7H5O2. And that is for benzoic acid. So the last one that I have here is arsenious. So again, I have acid, so I automatically have hydrogen. Okay, so acids, hydrogen. So then I can look at arsenious. Well, it's got an OUS. It doesn't have a prefix, so I know that it's not IDE. So arsenite. So arsenite is what I'm looking for on my polyatomic ion sheet. So, oh, there it is, arsenite, ASO3. And it's got a 3 negative charge, which means I've got 3 hydrogen atoms that are bonded to that. So then H3ASO3. The suffix of the anion gives me the name of the acid. Okay, so if I've got IDE, I'm going to have hydro, the root word, ic, acid. Okay, and if I have ATE, I don't have any prefix, I just have the root word, ic, acid. And then if I have the ITE, I have the root, OUS, acid. Now, there's a couple of root words that are not really known, essentially. So the root for phosphorus. So the root word for phosphorus is phosphor. Okay. So the root word for phosphorus is phosphor. The root for sulfur is sulfur. It's the same root. Okay, so the root word for sulfur is sulfur. The root word for phosphorus is phosphor. So anytime you have phosphate, so H3PO4, that would be phosphoric acid. I think it's just to make it sound better. So phosphic acid doesn't sound good. Phosphoric sounds a lot better. So remember, acids, in order for them to be an acid, they have to be aqueous. If they are in any other state, you write hydrogen and the anion name, whatever the anion is. Okay, so hydrogen and the anion name. So hydrogen chloride is HCl gas. So that was learning objective 8, which was to name and write formulas for acids.